Hi. So in this demo, I want to show off how you can deploy microservices to Kubernetes through Octopus. And we'll leverage a couple of the unique features of Octopus to make this process repeatable and easy for teams. So the service or the microservice stack that I want to deploy here is one provided by Google. It's this online boutique sample application. And this diagram here shows you the makeup of the individual microservices that go into this boutique store. And we'll be deploying this application to Google Cloud, a Google Kubernetes cluster here, which I've created before the demo. So the first thing I want to do is in an empty space here, what I want to do is start building up the process of deploying this microservice application. So to do that, we need to create some environments to deploy our application into. And to do that, we'll go through the infrastructure and environments tab. I'll just add the development and test environments for this demo. The next thing we'll need to do is create the Kubernetes cluster. But before we do that, actually, we'll create the account that we'll use to connect to the cluster. That's just going to be a username and password account. And we get those details from this show credentials section here. So the username is admin and the password is just a randomly generated string in this example. So we'll save those there. Then go to the deployment target section and add the Kubernetes deployment target. So we'll add one target per environment. So we'll call this GKE dev. That goes in our development environment. It takes the role GKE, and we'll use that username and password that we just created before. The IP address is this one here. That's an HTTPS endpoint, and I'll just skip TLS verification for now. Now, each of these environments will be represented in the cluster by a namespace. So we will call this MS demo dev. So the microservices demo dev namespace represents the dev environment inside our shared cluster. And so we'll just check the health of that. But while we wait, we'll go ahead and create the second target to represent our test environment. And so everything's going to be the same, except for some of the names and the environment associations. This URL is the same. We're skipping the verification. We will use different namespace though to represent the test environment. MS demo. Okay. So if we go back to our infrastructure tab, you should start to see some of those health checks have gone through okay. Yep, so the health check of our development environment has worked, and the testing target will also come up shortly as well once that health check completes. So to get started then, we will create a project. Now, so we'll if you look at this map here, what we want to do is start with one of the services that has no downstream dependencies. So you can look at services like email service, payment service, shipping service, ad service. These are all ones that have upstream dependencies, but have no downstream dependencies. So they can be deployed on their own and they will start running without requiring anything else to call out to. So we'll actually start by creating the ad service here. And so to deploy these applications, we'll use the deploy Kubernetes containers step. And this is an opinionated step that merges a number of different resources into a single deployed unit. And if we look at the YAML actually that makes up these services, we can see that we have this pattern of the Kubernetes deployment, and then a Kubernetes service paired with it. And so that happens over and over. So again, we'll have the shipping service paired with the shipping deployment. We'll have the currency service here paired up with a currency service deployment. So that pairing of deployment and service is a pattern that's repeated over and over. The other thing to notice about these deployments is that they're actually very similar. The structure is quite often the same. So if we look at the add service here, just paste that into a diff tool. And then we go and look at something like the shipping service, just randomly. We'll see they share a lot of the same structure. So it's a container with an image, obviously, that exposes the port. They all have varying environment variables. They all have readiness probes and liveness probes, and they all define these resource requests and limits here. And so this pattern of, or this YAML structure here is something that's repeated over and over, and actually almost all of it could be abstracted away into a convenient reusable template. And so we will do that as a way of providing a template that developers can use to just plug in the few variables that they know are unique to their particular deployment, and our template will take care of the rest and reduce some of this copy and paste here, especially things like service port here that's mentioned a couple of different times in your readiness probes and liveness probes here, and also in the associated service as well. So we can reduce some of that copy and paste that people would have to go through. So to do that, we can, actually I do have to create a Docker feed here. So if I go to my external feed, so you'll notice the containers here are from a Google Container Registry, Docker registry. And so we'll create that as an external feed. So to do that, we just use the gcr.io URL here. To test that works, I'll grab one of these images, just make sure that Octopus can find that. Yep, and it can, so that's all good. So I'll just refresh this. And I'll add that container step again. So what we want to do as part of this step here is basically build up a reusable template. And the easiest way to do that is through this, the ability to edit the YAML that defines the values behind this user interface here. And to do that, what we would do, so the process we would follow is something like this. We would take this YAML, and then we would start replacing these hard-coded values with references to variables. So the name of the service here is repeated in a couple of different places. So we would use a variable like service name, for example. And for things like container ports, we would do something like this, service port here, and that's also referenced down in here, as well as the liveness probe. And so you can see what we want to do is get to a point where the YAML here has all of the unique values for a particular deployment replaced by a variable. So I won't go through and do that one by one here. I do have a pre-created generic version. As you can see, all the values now, except for some of these ones that are just going to be common across everything, have been replaced with variables. So one thing I do want to call out is this variable structure here, where we reference, or where we wrap up the particular variable in this if statement. And so what this means is that if this variable has any value, then the returned value here is going to be whatever in between the start and the end of the if. And so we do this because termination grace period wasn't common between all the steps. Some of them defined it, some of them didn't. And so we want to allow our template to simply not define any value here. And if it's not defined, the resulting value will just be an empty string. And Octopus knows that an empty string for some of these values just means don't include this particular parameter in the resulting YAML. Just leave it blank, and that avoids any of the validation errors that you might otherwise get from a blank YAML property. So we've done that in a couple of different places, the termination grace period, a lot of the settings for the readiness probes also have that kind of structure. The other thing we've done here is used the new env from value, and that was included in Kubernetes 1.16, I believe. And what that does is allow us to include all the values from a secret or a config map, and we've used a secret in this case, and include all their variables as environment variables in the resulting pod. And so this is a convenient way of getting a variable number of environment variables into your pod, removing that from the deployment itself, and just kind of offloading that into an associated secret or config map. So the name of the secret here is something we'll create in just a little bit. So we've used this hard-coded initial prefix of my secret, and then added this dynamic suffix of the deployment ID reduced to lowercase. And so one of the opinions in this particular Octopus step is that resources that a deployment relies on should be immutable. And so you can imagine a situation where, say, version 1 of your deployment has an associated config map with some variables, and you go ahead and deploy version 2, and version 2 has the config map associated with version 2 is slightly different. It might have new variables, it might have changed some of the values, for example. And so by ensuring that associated resources like config maps are immutable and tightly bound to a specific deployment, what we can do is ensure that as that cutover from version 1 to version 2 happens, version 1 still has the old config map available and ready to read, while the new version of your deployment has its own associated config map. If you didn't do that, you're kind of left in this awkward, undefined position of version 1 of your deployment is now, for a brief period of time, referencing version 2 of your config map. I mean, that may be fine, but there's going to be a lot of cases where that will just lead to unintended results. So what we have here is this tight coupling of a secret resource here that has a unique name based on the ID of the particular Octopus deployment. And so we'll see actually where this secret is created shortly. One thing I will... no, actually, we're good here. So I'll just click done. And as what we've done here by saving that YAML is actually translated all those properties back into the user interface. So you can see here the service name is good. This is the pod termination period. The container itself has been defined with a whole bunch of those variables. And so that now sets up our deployment as a template. So we do have a number of other resources that are tied to each deployment. As we saw, each deployment has a service paired with it in the original YAML. We won't actually be using any of the ingress config map or secret, even though we actually are using secret. We're going to define that as a custom resource, which I'll enable here. All right, so the next step then is to add that secret, the service that's paired with each deployment. And again, we'll do that through a templatized YAML definition here. And you can see all these values, all these variables are things we defined in the original deployment. And so this is one of those cases where there was a lot of duplication and copy and paste that we can remove through the use of common variables and templates. So I click done there. Again, we can see that the UI has now been populated with those values. So this custom resource allows you to define basically any Kubernetes resource you want just by supplying the raw YAML. And so we're going to do that to define the secret that will be used to expose all the environment variables in our pod. And so the YAML for that looks like this. And so how this works is that we will have a number of variables grouped up grouped up in the group, I guess, called environment variables. And for each one of them, we're going to create a record under this data. That is the name of the environment variable and the value encoded to base 64, because that's just how secrets encode their values. You can see here the name of the resource was my secret. That was that fixed prefix. What Octopus will do when this deployment goes through is actually append that dash and then the deployment ID, or the lowercase version of the deployment ID, to it. And so this is one of those where one of those opinions of this step comes out, that all the associated resources with the deployment should be immutable and tightly bound. And we make them immutable by giving them unique names. And the unique name in this case just has the suffix of the deployment ID. So even though this YAML only includes the metadata name, my secret, the resulting resource will be a secret with the name my secret dash deployment ID too low. Okay, so let's go ahead and save that. Now what we want to do is extract the values of this step out into a reusable template that we can use for all the different services that were included in this boutique store. So we want to reuse this template for most of these services here, because they mostly follow that same pattern. So to do that, we'll go through and click this overflow menu and click extract step template. And so what you'll see is actually all the values now have been removed, and this step now defers to the template. So we'll save that change and then open up the resulting template. And so as you can see, the values here are what we exposed from our from the step originally before we deferred it to this template. And so our job here now is to just take all these individual variables and expose them as parameters that the inheriting steps can define for themselves. So I've created a list of the parameters just off to the side in a text document, so I'll just paste them in one by one. Service image is a bit of a unique one. So if we go back, I'll go back and have a look at the container definition. But this is actually a package that we want to select. This is a Docker image. And to do that, we select this package type here. And so we will have to go back and link that up. But I'll just finish filling out the rest of these parameters. So this process of templatizing Kubernetes deployments, it's a little bit tedious to start with, but hopefully we can see the value that this brings once we begin adding all our individual microservices. And we've then reduced the process of defining a microservice down to simply defining the unique values that make it up. So these are all the variables that were included in the deployment and service YAML. And as I mentioned before, we do have to now link up this service image. And so what I want to do here is actually let the project select the package. And we'll do that through this service image parameter here. Okay, so if I save that, we will see that the original step needs to be updated to reflect the new version of the step template. And we'll actually give it a image of, because this was the add template, sorry, the add service. We'll go ahead and define the Docker image as that. Yep, and so that's found successfully. Okay, so let's go back to our step here. Now I could have defined all the values for the add service, but I'll actually go ahead and, as part of that upgrade, I should say. But what I'll do now is go ahead and define them here. So just find that YAML off screen. So what we're going to do is start migrating the values from this YAML, or the unique values from this YAML, back into the step. So the service name was obviously add service. Termination grace period was set to 5. Oh. Now the port was 9555. We had 200M for the CPU request. Memory request was 100 meg. Limit was set to 300 for CPU, and this was set to 300 meg. Readiness, initial probe delay was 20 with a period of 15. Liveness was again 20 with a period of 15. And we had no timeout here, which is to say we had no, we didn't have this third argument on the readiness probes or the liveness probes, which we do have in some of the other examples, which was this one here. But for the add service, we just leave it blank. All right, now one thing I do want to check, actually, I don't know if I remember to set the namespace on these targets. Actually, one of the health checks has failed. I should check that. Right, yes, so I did set the namespace. I do want to check that failed health check though. So the health check goes through basically just as a kubectl version, and that ensures that the kubectl tooling is available, as well as the ability to connect to the server and get the version. So that's what's being run in the background here. Just have a look at the previous failed task quicker. Oh, right. So what you can see here is it's tried to connect to port 80. That just means I didn't set the URL correctly. It should have been HTTPS, not HTTP. Just fix that up. That should resolve that issue. I'll leave that running, and we'll come back and make sure that worked okay. Okay, so we've got our add service. We have extracted it as a template. We've put all the add service specific values back in. So all that's really left now is to go ahead and deploy it and make sure it works. So let's create a release here. And one thing we'll notice is that the version of the Docker image is not quite what we want. So as we can see, the version that it's selected as latest is this hash. Actually, we really want these nicely versioned values here, 020, and those are actually the ones that this YAML file references. So one of the nice things we can do in Octopus is use channel rules as a way of limiting down the versions that will be selected as part of a release. And in this case, we want to use, basically we want to say anything between 0 and 1. So that'll include our version 0.2.0. And so we do that with a version range like this. So this says anything between 0, anything between 0 and 1. And actually, if we go to the rule designer, we'll see how this starts to play out. So all these versions here are clearly between version 0 and version 1. This one here, this is actually interpreted as version 31, and then with a pre-release tag of df60f. But in this case, obviously, it's the leading 31 here, which has been interpreted as a version, is well outside of the range of 0 and 1. So if I save that and go back and try and create a release again, we'll see that so we'll see that Octopus has applied that version range and selected the correct version for us. So let's save that and deploy it to the development environment. Oh, okay. So this, I forgot to set the target on the step. So if I go back here, I will have missed the, on behalf of, this should be GKE. Try that again. So what we can see from the logs here, if I just open up the verbose mode, we should be creating 3 different resources here. So the first one will be that secret. And actually, I need to go back and define the environment variables that will go into the secret. So this deployment may actually fail because those haven't been set. But we do have the secret here. It just had no data because no variables actually matched. Then we have the deployment. And as we can see, all those variables that we placed into the template have been re-added, and the resulting YAML has come up as we expect. And then we have the service. This one here, and that service exposed our gRPC port from anything that matched this label definition here. So I'm actually surprised that worked, but obviously the ad service is a little bit more tolerant than I expected it to be of missing environment variables. But what we will do is just go back and make sure that they're added. So if we look at the ad service here, and service, you can see that it has one environment variable called port. So to find that, we need to go in and add a variable in a specific format. So I'll go back to my project, variables. And so the format of the variable is this. So that environment variables, that was the kind of the name of the group. The value in the parentheses here, or the square brackets, is the name of the environment variable, and value is just the parameter of this particular group that we're exposing. And so in this case, we want an environment variable called port, and the value of that should be 9555. So let's add that. And actually go ahead and redeploy that so we can see how that variable gets into the secret. So again, if I go back to the verbose logs, we get to see the YAML that's created. Scroll down, right, so we can see that the secret is now being created with that one variable, or that one value, and this is the base64 encoded version of our port number. All right, so what we now have is a template that we can use to define all the other, or most of the other, I should say, microservices that make up this particular stack. So let's pick the next one, which is going to be email service. So that's another one that only has upstream dependencies, not downstream. So project, I'll add a project. Let's call this one email service. And we're going to reuse that template container. So that's this template here. Remember to select the role, and then we go through and start populating the details for this service. So this one had email service, grace period of 5. It uses the email service image. It exposes 8080. It is asking for 100 CPU and 64 meg of memory. It's limiting itself to 200 CPU and 128 meg of memory. So this is a case where we don't actually define some of these values. So there was no initial delay defined in the original YAML. We did have a period of 5. Again, no initial delay, but a period of 5 for the liveness, and no prime timeout here. And that's it. So the next thing we need to do is go through and add those variables that will populate our secret. So if we look at our service here, we have 2. We have port and disable profile. So the port one will be just like we did before. So we said that was 8080. And then we have the disable profiler. So that takes the format of, let's just replace the in between the square brackets there. And that was set to 1. Okay, let's create that. And oh, again, we have to set that channel rule just so we're not grabbing a checksum, or probably a git commit actually, as the version. There we go, selecting O.2.0. So we can see those 2 variables have now made their way into the associated secret. This was something I didn't point out before. This was the final name of the secret, and as you can see, it has that prefix and then the unique suffix for each deployment. And if we look down here, the deployment YAML has worked as we expect. This is that secret ref, and again, you can see how we've leveraged that unique deployment ID to link this individual deployment to its associated secret. And then we also get the service as well. So what I'll do is actually just pause the video now and go through and create the rest of these common services. There's just a fair bit of copying and pasting that needs to go on, but you don't need to watch that. And so we'll come back once they've all been set up. So I'll see you in a little bit. Okay, so I've gone ahead and created most of the services here. All of these services are ones that follow that same templated pattern, so we could reuse that step template. There are a couple of deployments that don't quite follow that same pattern. The database here, Redis, is one. So we'll create them as standalone deployments. But fortunately, that's still quite easy to do. So what we'll actually end up doing is just pasting in that same YAML like we did to create the initial template, and that will give us the unique deployment for these kind of special edge cases. So to do that, we'll use the same step, container, this one here, and we'll go ahead and paste in the YAML to populate this GUI. So we'll just paste that in, and as you can see, that's gone through and populated all the settings here. And we'll need to do the same for the associated service. So we'll scroll down to the service, we'll paste that in there as well. I will just disable some of these features that we're not using and save that. Now, if we look at the image that's being used for Redis, it's actually this Alpine tag. And so what I want to do is set up a channel rule that will allow us to select just that tag. So the way that works is we use a regular expression to match what we consider to be the pre-release part of the version, which is that plain text Alpine. So this regular expression matches the start of the string, matches the plain text Alpine, and then the end of the string. Versions that are just plain text are considered basically 0.0.0 version. And to enforce that as part of a version range, we use this rule here, which says basically any version less than 0.0. And that works because any version with a pre-release tag is considered to be less than the just a plain untagged version. So if we set that up there and go to create release, yeah, we'll see that that particular tag has been selected for us. So we'll go ahead and deploy that one. The other deployment that doesn't quite match that same templated pattern is the front end, and that's this one here. You can see the health checks are different. They're not using the gRPC health checks, and so that's why we couldn't use that template. So I'll just grab that YAML. We'll create a new project called front end. And so again, we'll use that same deploy Kubernetes containers step. Oh, the wrong one, actually. I picked the template. I don't want that one. This one. Okay, so we paste in the YAML for the deployment, and we paste in the YAML for the service. And again, we'll just disable these unused features here. Now, the other thing to note about the front end is that it actually has two services. This one's the internal one. It's a cluster IP, so that means it's not publicly accessible, but it has this second one that is publicly accessible. And we will deploy that through a second step that is set up to specifically deploy a Kubernetes service resource, which is this one. Again, it's just a case of pasting in the YAML. You can see it's set up a load balancer here. And so by creating this load balancer, what will happen in the GKE cluster is like a network load balancer will be created with a public IP address. And that's how we get access to the service. sorry, to the front end. So let's go ahead and create a release for that one. Oh, and we'll have to set up a channel rule there to get rid of that hashed value for the Docker image. Let's try again. Yep, there we go. So version 0.2. All right. Now I did not deploy some of these services because they were relying on that Redis cart. So I'll just go ahead and create some releases here quickly. Now that the cart backend, sorry, the database backend is deployed. Oh, that's another one where I forgot the channel rule. And shipping, again, forgot the channel rule. All right. Okay, so checkout has failed. Oh, okay. I must have not defined a value here. Oh, yes, I've done a copy and paste fail here. So that was the checkout service. Should be 50-50. Okay, so at this point, once our checkout service is completed, we should have the full microservice stack deployed to the development environment. So one thing we are going to need to do, though, is find out what the IP address of this front-end load balancer was. So if you recall, we created a second service to expose the front-end application, and it was of type load balancer. So that's this type here. And querying all these kind of ad hoc queries of a cluster are a really great use of runbooks. So what I'll do is create a runbook here, and I'm going to use a community step template called inspect resources. And this is just a step that wraps up calls to kubectl to do various common queries of resources in the cluster. So what I'm going to do is have it inspect the service resources, want it to describe those resources. And actually the name of the resource that we're interested in was front-end external, which was, go back here, the name of this load balancer service. I'm just going to type that in there. Create artifact allows us to create a text file that has the output of this kubectl call. So if I save that and run it, now we do want to query the resource in the development environment. So we can see I'll just expand this out. You can see the kubectl command that was called. I want to describe the service called front-end external. And here we can see the load balancer ingress. That's the public IP that we want. So I go back to my dashboard, just make sure everything's green. It does look like that is the case. So let's put that in and Here is our microservice deployed in our development environment and ready to use. So this, what we have now is an example of deploying all of our microservices to a single environment. We've seen how we can use templates to kind of remove a lot of the boilerplate that developers might otherwise be expected to implement as they deploy new services. When you use that step template, you really just have to plug in a couple of unique values for your own particular service, and you're good to go. And you can be assured that you've deployed your application in a way that's standard and consistent across your organization. So the next challenge here then is, how do we get this into the test environment? We have a dozen or so services that need to go across, and it's actually not very efficient to be deploying them one by one in order to populate a new environment. So what we'll do is make use of another step in Octopus called the deploy or release step. So I'll create this this project in a new, or the steps in a new project called Deploy Microservice Stack. And so what we want to do is bundle up the deployment of a number of different projects so we can move from one environment to the next with a single project. So if we look here, I'll show you how this works. Deploy a release. So it's this step here. And what this step does is treats a release in Octopus as kind of a package, really, that you can select during deployment of this step. So we will, if we go back to our map here, we kind of want to deploy again in the same reverse order that we had before, where all the services that have no outbound connections and no downstream dependencies, I should say, are deployed first, and we work backwards towards the middle here. So we want to deploy something like the email service to start off with. And that is this. So we want to select this project here. I'll just save that. Might just clone this step to make it easy. Yep. And then the next one will be, let's go payment service. And then the next one will be, oh, actually I did the wrong one there. I'm going to rename this for email service. So this one will be, maybe just close this. Shipping. And after that, we will have let's do currency. And then we'll do product catalog. At that point, we should do the we should do that database. So let's do Redis. After Redis, we can do the cart. Okay, and then we can do add service. After add, we will do recommendation. You can do checkout and then front end. Okay, so we have 11. Just double check that that actually matches what we expect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, so we got them all in there. So what we can see is that when we create a release of this, we get to select the release of another project's release here. So most of these will be at .1, but I had to redeploy some of them a couple of times. So it'll be a .2 and a .3. So what we'll do is save the release of this kind of meta project. And we'll go ahead and just push that to deployment. So nothing will really happen here because all these releases are currently, I mean, they're already live on the system. So we don't expect any particular changes to happen here. By deploying this meta project to development, we can then promote it through the test environment. So what we can see here is as we deploy this meta project, each of these will start to be deployed in turn. So this one here will be will continue to run, and we'll just see individual projects popping up with their new deployments. And once that's finished, we'll go ahead and then promote this release out to the test environment. So I'll actually just pause the video for a second while all these run through, and we'll get up again once that deployment has succeeded. Okay, so the deployment of this project here just completed in the development stack. Actually, that was kind of unnecessary. We didn't really need to wait for all those to deploy. The settings in that deploy or release step that we could have used to remove that. I'll just show you that now. So what we could have done here, we left the default as run deployment every time. What we could have done is selected one of these other options. If it's not the current release, or if the selected release is higher. And so if we'd selected either of these, the deployment back to the development environment just would have basically clicked through as a green deployment straight away. So I'll actually just leave it as the default for now because we've already run the deployment, but that's just handy to know in future. So if we go back to here, then we can promote this release out to test. So I'll just click that now. And so what this is going to do is take the releases that we've captured in that the releases of the individual projects that we've captured in this meta project, and we're now going to push them across to the test environment. And so what we'll see here is now by deploying this one single meta project, we in effect are deploying 11 different child projects as a group. and in a particular order. So for microservices, ideally, they should be able to function or degrade gracefully if one of their downstream services is not available. So for example, the checkout service should be able to run ideally in a degraded state if email service is not available, for example. But there are a lot of cases where that's not true, and you do actually have to deploy things in a particular order. And what we have here, this order here, captures that deployment order for us if such a deployment order is actually needed. So if I go back to my dashboard, we can now see how the test environment is starting to fill up. So we've already deployed the email and payment services. We're onto the shipping service, and each of those deployments or the versions of the releases in the development environment will start to cross over through to test, just as these individual steps work their way through. So again, this will take probably a minute or two. So I'll pause the video again, and we'll rejoin once the test environment is ready and up and running. Okay, so the deployment of the microservice stack has finished in the test environment, and as we can see, all the projects now have been deployed. So the last thing we really need to do is find the public IP address of the load balancer for our test environment. So if I go back to my front-end service here and go back to the runbooks, we can rerun that same runbook in the test environment, and we should be able to see that public IP address. And that's it here, the load balancer ingress. Paste that in, and here's the online boutique for the test environment. Actually, just to prove that was different than the last one, let's go back to our overview and find the last run. So this one here was in the development environment. And this was the IP address here. So 234 versus 169. We can load those up side by side. So we can see the two environments now are running side by side in a single Kubernetes cluster. They've been isolated from each other through namespaces. So we've used namespaces as a way of partitioning up our Kubernetes cluster to host multiple environments. And that's it. So we have now successfully deployed a complete microservice stack into multiple environments, and created a reusable process that anyone can now either use to deploy new services if they need to, or manage the deployment of the existing existing stack. So just to recap what we actually did here, we created a step template, which was this one here, that abstracted away the YAML, the common YAML across all the different, well, across most of the microservices, and this left us with an easy to use template that we could simply plug in the unique values for the various microservice instances that we wanted to deploy. For the deployments themselves, we used some channel rules as a way of ensuring that we got the correct package. So for most of these services, we wanted the 0.0.2 package, which we've defined through this version range here. For things like the Redis cart, which was simply a plain text version, we used a version rule that said match that plain text as a pre-release tag, and then the version range said basically anything up to version 0.0. And just recall that was because any version with a pre-release tag is considered lower than a plain version. So 0.0.0-Alpine is considered lower than 0.0.0. And so this version rule gave us access to this plain release, this plain tag here. We made use of a lot of the copy and paste YAML just to quickly import existing service definitions or deployment definitions. So that's through this field here. So by copying and pasting, we can quickly populate this opinionated UI step and get everything up and running. And then finally, to allow the promotion of an entire stack from one environment to the other, we made use of the deploy and release steps here. So we have a project that captures the individual deployments of the individual microservices as a deploy or release step. And by promoting that from one environment to another, we can basically capture the currently deployed state of one environment and migrate that across to the next one with a single deployment of this meta project here. So I hope that this demo was useful, and if you have any questions, please reach out on the comments of the associated blog post. Thanks a lot, and I'll see you next time.